Hello everyone, I am Rachel Ansaya and I am 20 years old, a first year college student from BS Legal Management. And for today, I'm going to walk you through another portion of mathematics in modern world, which is apportionment. So what is apportionment? Okay, so right now I'm going to give you an introductory about what is apportionment. So apportionment, it is the problem of dividing up a fixed number of things among group of different sizes. In politics, this takes among groups and this takes the form of allocating a limited number of representatives amongst voters. This problem presumably is older than the United States, but the best known ways to solve it have their origins in the problem of assigning each state an appropriate number of representatives in the new Congress when the country was formed. States also face this apportionment problem in the defining how to draw districts for state representatives. The apportionment problem comes up in a variety of non-political areas as well. So if you can notice, it's not all about just solving, but it is highly related with politics. So why is that? Apportionment, it is like one of the most important functions of the decennial census. So apportionment measures the populations so that the seats in the U.S. House of Representatives can be correctly apportioned among the states. So right now I'm going to tell you the rules of apportionment. First things first, the thing being divided up can exist only in whole numbers. So when we say whole numbers, like there are no decimals or fractions, just whole numbers. Second, we must use all of the things being divided up and we cannot add anymore. Next, each group must get at least one of the things being divided up. And lastly, the number of things assigned to each group should be at least approximately proportional to the population of the group, which means exact proportionality isn't possible because of the whole number requirement, but we should try to be close. And for an instance, if group A is larger than group B, then group B shouldn't get more of the things than group A does. So let's proceed. In terms of the apportionment of the United States House of Representatives, these rules imply. So take note of these four things that we need to remember, especially on the terms of the apportionment of the United States House of Representatives. First, we can only have whole representatives. Like a state can't have a 3.4 representatives, as what we have mentioned earlier from the first rule that the things being divided can only exist in whole numbers. So it means that you cannot have like 3.4 representatives, things like that. The next thing is we can only use the current 435 representatives that is available. So we cannot just like get data that is not available. If one state gets another representative, another state has to lose one. So am I making things clear here? Every state gets at least one representative. Take note of that. That should be like remembered, or that should be noted as well. And lastly, the number of representatives each state gets should be approximately proportional. When we say proportional, balance to the state population. So this way, the number of constituents each representative has should be approximately equal. Just like what I've read or what I've discussed earlier, it should be proportional or equal to the state population. So let us proceed. In apportionment, there are different methods. There are different ways of solving this or the data that is being given. So first, we have the Hamilton's method. Again, it is the Hamilton's method, the first method of like the way, one of the ways to solve apportionment, also known as the method of the largest remainders, and sometimes as Vinton's method. So a brief discussion about Hamilton's method. It is a function used to solve a problem of optimal optimal control for a dynamical system, it can be understood as an instantaneous increment of Lagrangian expression. So it is the problem that is optimized to over a certain time period. So that is Hamilton's method, like a brief description of what kind of method this is. Next one here we have the Jefferson's method, also known as the greatest divisors in and in Europe as the method of the Hunt or the Hagenbanch-Biscoff method, if I'm not mistaken for that. So the Jefferson's method, it avoids the problem or of an apportionment resulting in a surplus or a deficit of house that will result in the correct number of seats being apportioned. So that is Jefferson's method. Next one, we have the Webster's method, also known as the Webster's-Wilcox method, as well as the method of major fractions. So when we say Webster's method, it's a modified version of the Hamilton or Vinton method. When we say modified, it's like the simpler form of that kind of method. And after the state populations are divided by the divisor, those with quotients that have fractions of zero point 0.5 or above are awarded an extra seat. So states with a quotient that below zero point 0.5 have the fraction drop. The difference between the three methods is that the rule for rounding off the quotas. So Jefferson's method rounds the quotas down to their method rounds, and then Adams method rounds the quotas up to their upper quotas. In Webster's method, on the other hand, it is the quotas either up or down following the usual rounding rule. Is that all clear? So next one we have the method. The next one is the Huntington rather Hill method. So when we say Huntington, it's like the method assigns seats by finding a modified divisor D such that each constituency priority quotient, its population divided by D using the geometric mean of the lower and upper quota of the after quota for the divisor yields the correct number of seats that minimizes the percentages and differences in the signs of subconstituencies. Lastly, what we have is the Lowndes method. All but Lowndes method has been used to apportion U.S. Congress. So we have here 5 methods to solve or to get the apportion of a certain information or data. First we have the Hamilton. Next we have the Jefferson, Webster method. Next to that is the Huntington. And lastly, we have the Lowndes method. So let's proceed to the examples or the given examples or word problem solving for us to understand better what kind of methods or what kind of discussion we are having right now. So let us proceed for the first word problem. Okay, it says here, suppose a nation has 4 states with population show below. If you can see here in the table that is being shown, this has data, informations, and a representative body with 60 seats. How many seats should each get? So we have here the 4 states that is being represented by the state A, B, C, and D. So in a population, state A has a population of 74,285, 63,614 for the state B, 42,355 for the state C, and then the population 27,383, total of 207,637 in population or in total. So in a fair share, we can get here the in fair share, we have here the 21.47, 18.38, 12.24, 7.21, and 60. So in lower quota, it will result as 21, 18, 12, 7, 58, and then it's like the second, third, fourth, and first in priority, which has seats assigned. Here in total, if you can see in this table, seats assigned 22, 18, 12 for state C, and for the state B, it has like a total of 60 seats in all. So if you can notice, I am just like explaining it briefly for our next presenters or next discussions to give more clarification or to broaden the subject. So by the way, this method is the Hamilton, or the first method, the Hamilton method. So take note of that. Next, this one is a Jefferson's method. So if you can see here, this is the first table, no, and the university offers tutoring in English, mathematics, human resources, and philosophy, four subjects in all. The number of students enrolled in each subject is listed below. As you can see here, the enrollment, the data being shown. If the university can only afford to hire 21 tutors, determine how many tutors should be assigned to each subject using Jefferson method. So if you can see here, the subjects are displayed: the mathematics, English, human resources, and philosophy. So for each subject, there are different data that is being displayed. Mathematics has 360 enrollees. English has 315 enrollees. Human resources has 135 enrollees, while the philosophy has an 80 in total. For if you are going to sum it all, it's going to be 890 enrollees or in the enrollment period. So how can we get the quota? So here we can see here, right? Like 890. So we will have the quota here, 8.400, 8 rather, 4.494, English 7.433, 3.185, 1.888. Initial 8,731 and 19. It should be matched here. So I will show you in the next table. Okay, this is what happened. The standard divisor, as what is shown from the first table, it was 42.38, 42.3810, and the simplified divisor was 42. But since it wasn't equal to the total, equal in final and in initial, we will have the simplified divisor reduced. So here we can see here quota 9, 7.87, it becomes it has become 3.375 for 3.185 and 2 for philosophy. And the initials were 9, 7, 3, 2, 21. And then the final, we can see here that it's proportional, 7, 3, 2, and 21. So this table, this problem solving shows the Jefferson's method. Actually, the first three steps in the Hamilton's method are just as the same as the Jefferson's method in the first three steps as well. So you just have to take note of the standard divisor and simplified divisor and make sure that it will be proportional. Okay? For the next problem we have here is the Webster's method. So the legislature in a state has 44 seats, apportions these seats to the 5 counties using Webster's method. That is counties, not countries. So counties, these are the counties: Adams, Grant, Colton, Davis, Hayes, and here, their populations are being shown: 365,000, 189,283,289,284,000, a total of 1,582,000. So again, just like the first one, we have to get the quota. So let's, this SD means the standard divisor. So we have to take note and we have to really know how to get the SD. And our standard divisor for this one is 35,954.5455. So here in our initials, we have here, for Adams, we have 10, Grant 14, Colton 7, Davies 5, Hayes or Hayes, it's 8, a total of 44. And we can see here on the other side for the final result, it is proportional or it is balanced, it is the same. So these are the portions seats of the five counties using Webster's method. Okay, let's proceed. Okay, this is, I believe, the next one. We have here the next one is a university offers tutoring in English, mathematics, human resources, and philosophy. The number of students enrolled in each subject is listed below. The university can only afford to hire 22 tutors. Determine the apportionment of the tutors using Huntington's Hill's method. Okay, from the previous one, we had 21 shooters only, but right now we already have 22 shooters. So using the Huntington's Hills method, we are going to determine the apportionment of the tutors. So just like the previous topic, we had just the same subjects: mathematics, English, philosophy, human resources. And here in the table, the data are shown for how many enrollees are there, and also the quota here. Our standard divisor for this problem is 35.4545, and our MD or the modified divisor is 37. Lower quota is 10. We have why 10? Because in quota it shows there 10.270. In English 6.486, making it 6. 2.838 making it 2. And lastly 1.486 having it as 1. And geometric mean, if you can see on the lower area or the lower part in the right part, the geometric mean, that is square root of 9 multiplied to n plus 1. So we can see there, our n here is 4. And then we are going to add it with 1 and then have it as squared. So squared, have it squared. Okay, geometric mean 10.488. If you have calculators, you can also solve it. 6.481 for English, human resources 2.499, and philosophy as 1.422. 1.414 rather. So for our final allocation, there are the apportionment of the tutors using the Huntington's Hills method. In mathematics, there are 10. In English, there are 7. Human resources, there are 3. In philosophy, there are 2. A total of 22, which match with 22 tutors of the university. Okay. Next, lastly, a teacher wishes to distribute 10 identical pieces of candy among 4 students. Okay, 4 students based on how many pages of a book they read last month using Hamilton's method. So this one is also a Hamilton's method. So if we can still remember earlier, we have discussed Hamilton's method. First things first, among the methods, and we are just going to use the same procedure for this problem solving. So the table below lists the total number of pages read by each time. So here we have Alan, Antonio, Alex, and Lucas. These are the 4 students that the teacher wishes to distribute 10 identical pieces of candies. For the quota, we have 5 who's 1786, Antonio 230, which is the 2.0536, Alex 1.6071, and Lucas 1.1609, making it 10. And an initial 5 to 111. So this one a total of 10, and then a final making it 10. So the um this is the result of the apportionment using the Hamilton's method, just like the earlier. So these are some of the brief explanation when it comes to solving apportionment in different method. We have the Hamilton, we have the Webster, the Jefferson, the Huntington's Hill, and I haven't showed the longest method, but these are the 5 ways that we can solve the apportionment or the information that is being given. So if you can notice, um, it's not just all about it's not just all about solving, but as well as comprehension and analyzation for the solving. So even though there were already five methods, there are still flaws for the apportionment. So flaws of methods in apportionment, this can be found in the Hamilton's method. First, we have Alabama paradox. It occur when an increase in the total of items to be apportioned results in a loss of an item for a group. The next one, we have population paradox, occurs when group A loses items to group B even though group A's population grew at faster rate than group B's. And then lastly, we have new states paradox, occurs when the addition of new group and additional items when the additional items to be apportioned reduces the previous apportionment of another um, of the another group. So these are the flaws of methods in apportionment. So we should remember this one because these are very important as well. So if you can notice, the word paradox, according to the Merriam Dictionary, Merriam-Webster, it says there it's a tenant contrary to received opinion, or it is something like the one having seemingly contradictory qualities of faces. When we say tenant, it means a statement of the meaning of a word or word symbol or sign. So that is what we say, what we call tenant or the definition of paradox. So again, we have three rather different types of loss of methods in the apportionment under the Hamilton's method. And please take note, there are five methods of way or five ways of solving a apportionment. First things first, we have the Hamilton. The next thing we have the Jefferson, and then also we have the Webster. Fourth, we have the Huntington's Hill, and then the last one, but not the least, is the Londes method. So again, the importance of this portion in this course is to give insight and also to find ways of the proportion or the apportionment of a given data or information. Again, that is the discussion that we just had today. I hope that you all learned something, and there are also different articles or different ebooks that we can find to have a um, deeper knowledge or deeper study of what is an apportionment. So that is all. I hope you all learned something once again, and thank you so much for listening. Sigap ka nga, pero okay na to. Di na ako mag-usap kay ka. Wala nag-recording pa mo din yun.